Hey guys, what's up? I'm Luthra, your your cybersecurity expert or mentor, whatever you guys want to call it. Let's call it a day. Just kidding. Okay, guys. So how's everyone doing? I think everyone has a great week ahead. Already had a great weekend. Expecting a great week ahead as well. So moving forward, I would say so. Today we'll talk about these topics: cloud, application, database, Fireball. What's Fireball? Should fire? I think this is wrong. It should be wall, not ball. Let me fix this. Yeah, Firewall. Yeah, database. Weird. Anyhow, okay. We talk about APIs, website ports, what's Ddos attacks, malwares, and penetration testing. Or is it testing? But testing doesn't sound good. Like testing is like, nah. Presentation is like, oh yeah, it's like fire or something sort. Maybe I don't know. Yeah, like it's like something hacking, and testing like downside, right? It's like crying or something. I don't know. Okay, move forward, guys. Anyway, let's leave it aside and let's get down to the bit top business one. Okay, previously already had talked about what is networking or how stuff works in networking and stuff like that. Right? Yeah, I got messages. Nothing so OP. Yeah, UOP2, bro. UOP2. Courses OP. Thank you so much. Hey. Okay, so I got a message. How long the course will go on? Let's see. I think most probably it will go on up till March, I would say. That's an expected time from my side. I would think everything will be covered by March, but I'm not sure. But March is what I expect. Okay, so let's come down to business now. How things go and what we'll talk about. So we will talk about networking, what a MAC address is, what IP address is, why IP address is required, why MAC address is required, how routers work, and how your MAC IP addresses are linked to each other. We have already discussed that in the last video. Those who have not watched the last video, go back, watch the last video, and come and watch this video. That would be the smarter way to move forward. Okay, so let's get down to business today. Thank you, calling me OP. Let me be OP. Thank you. It's more of people those who want to be looking for a job after college. I would say. I don't know. Let's just say for job, those are looking forward to. It's for counseling. It's for career counseling. Yeah, it's for career counseling. For people who are looking for job, I think you guys are not looking for job, so you don't have to call it this. Maybe you can call and talk to them. I don't know. Maybe if you want to. It will go. Yeah. Anyway, so let's talk about cloud. Right. Okay, let me wrap it up. Cloud. Okay, so let's talk about cloud. So many of you already have a decent idea about cloud, right? So you might have watched videos where we say cloud, rain. So we are not talking about that cloud. Let me get one thing absolutely clear. Okay, so this is not the cloud we're talking about. Okay, so they're getting sponsors, advertisements. What all we get? Are you creating money through ads? Okay. No, no. This is basically coding blocks number. So you can call it this number, and the people in coding blocks will talk to you guys if you are looking for some job, career, what are things you should move forward with, what are career options you have, and stuff like that. Okay, so this is not what I'm making money out of advertisements, right? So, right. So this is not the cloud we guys are talking about. Let's get one thing absolutely clear with you guys. This is not the cloud I'm talking about. So this is a cloud what people say. Like when someone talk to you and you tell you like, you know what, store the data in the cloud. They don't actually mean to store in the cloud itself. This is not what we're talking about, right? So cloud is extremely a vague term, I would say, right? So this is not what we're talking about. Let's put it all together. So what is cloud? Let's get to the point of that. So before the cloud came into the market, and we're talking about cloud these days, we used to have small computers, right? Many computers all together in a room. in your what, let's say in your office, right? So we used to have many servers. These are servers, I would say, right? So when you open an office, when you open your own office, or when you start your own business related to IT industry and stuff like that. Let me see my camera. Yeah, it's better. So IT industry and stuff like that. So you used to have servers where through you actually serve something, right? So we already have talked about servers and clients. Not if not, I will tell you. So let's dig into quickly dig into the part of servers. Okay, so what are servers? So when you open a website like Google.com or YouTube or Amazon or any website altogether, you open a website, right? So it's a browser you have. You already know about that thing, right? So it goes to a point. It's a big, many computers are there, and you get to know. You see a website, and it serves the website back to you, right? So that's how internet works. We already talked about that. Okay, so that's how it goes. I think the point of servers also has to be discussed. Yeah, it has to be discussed. Yeah. Okay, so we'll talk about servers now. So when cloud came into being, we used to have servers, right? So this is what people are talking about. Servers were everywhere. I got server, they got server, server. Cool, that's good. But I will give a brief introduction about this as well because that's part of my course. Many people might not have watched that video. I don't know. So I will talk about that. So coming to the point now, so let's say we used to have servers, many servers altogether, right? So these servers allow you to serve the data. So what does server means? Server means serving data, right? So that's how server works. You open a website altogether, whatever you see over there comes from a server. So how does server work, right? You have internet, right? So you have internet, you have a laptop to it. You open a website, it goes through internet some way, somehow, and it comes to a point of a server, right? That's how it's done through IP addresses. Now, all these servers are running on some kind of a port, right? That's important for you to understand. We'll talk about port now. This we'll talk about. We'll talk about it. Okay, so these all things are running on ports. What's happening? People are getting crazy about numbers. I don't know. Okay, these are called ports. Okay, so when we hit an IP address, we get to a server. Server is running on a port. Like for example, X server is running on Y port, and that is being served through it. Now, what is a port? Let's talk about ports now and why it's important. So coming down to point again. So what is a port? Let's say what is a port? Okay. So we got to know what servers are. Servers are basically a computer. It's just a computer which is running away from your house, and it's getting data from there to your browser. That's all. Like it's sending data, and the data is received to browser. For example, a server, it sends the data, your browser receives it and shows something or the other, like a cat picture, right? Something like this. Right. Cat picture. That's all. So not only cat picture, any picture together is being shown through server. So now, what is a port altogether? So port is nothing but a location where that server is running. So for example, when we talk about internet works on multiple ports, right? For example, 80 is for HTTP. 443 is for HTTPS, and so on. Okay. Give me a moment. Yeah. Okay, so that's for HTTPS 443. We have for, let's say, SMTP, right? It's a simple main transfer protocol. So we call SMTP. For SMTP, we have port number 25 called SMTP, right? It also works on 465 and let me guess, 587. All three different ports, different stuff. So these are called ports. So what are ports? Let's get to the bottom of it. So we have already talked about internet, right? So internet is what? Internet is nothing but a big area through which data has been transmitted. Yeah. Okay. We set it through properly first of all. Okay, cool. So we have internet like this. Click. Yeah. Cool. We have internet, right? So this is my internet. So now all the data is being transmitted in the internet, right? So let's say in internet. So all the data has been transmitted through internet, right? So something is going from here, here. So your mails are going through it, right? Let's say mails, your messages, your HTTP requests, and so on. So lots of things. Yeah, I'm talking about that. Just give me a moment, I'm explaining that. Just give me a moment. This is what I'm talking about. So a lot of things are going through internet. Even if you have your own internet at your house, like you have your Wi-Fi. So someone is sending messages, someone is sending mails, someone is talking about Googling stuff, someone is watching video on YouTube, looking at me at 8 o'clock in the night, evening on set. Like some people are looking at me at 8 o'clock Saturday evening and they have nothing else to do. Cool. Neither do I. That's the funny part. Saturday evening, nothing else doing, just watching a video on how the port works. Sounds cool, yeah? Cool. Anyhow, so these are called internet, right? So ports. So coming down to that, so many things are like many people do many things. So how to actually segregate that part altogether is based on ports. So mails go on a separate set of ports. Your messages go on a separate set of ports, and your HTTP request go on a separate set of ports. So all these things go on a separate sector of ports, and these ports hit exactly at the place. Okay, for example, your mails. So your mails work at port number 25. So if when a request or something has to be sent, it sends to port number 25. Server gets to port number 25 and sends further. If we talk about messages, right? So or we talk about HTTP request, so it's come to for port number 80. It goes to port number 80 and sets forward, right? So these ports can be visualized, or they're difficult to visualize. They can be considered as a way that this is the location in the computer where the server is running, right? So that's how ports are set. So when I'm talking about port number 25 or port number 80 for HTTP requests, what I'm actually meaning is to say that when we go to website, port number 80 is fixed for that, and that's how the data has to be transmitted through port number 80, and that's where the server is running. Why it's important? For example, I got one computer. Okay, I got one big computer, right? So on this computer itself, I'm running one mail server. So what is a mail server altogether? So mail server is nothing but a server which is responsible to handle mails. Okay, so a server responsible handle mails. So that's called a mail server. It's also running side by side a web server. Okay, sounds good. It's also running an SSH server, or maybe some other server as well, or other X number of servers are there. Okay, so there can be N number of servers altogether. An SSH server, web server, mail server. Come on, give me one. Come on, shoot me one thing else. A streaming server, right? Call it a streaming server. Okay, multiple servers are being run altogether. So now, when we have a connection through internet has just one connection through it, right? How does the packets, right? So how data is being transmitted through internet? The data through internet is it's sent through packets, right? So there's a packet over here. This packet contains several data information, right? It contains port number, which has to go. It contains your IP address, MAC address, and stuff like that, right? So it contains a set of packets, right? So these things, yeah, good question. I will talk about it in a while. I will. Well, cool. Okay, moving forward. Let's stop it. I don't think this is actually part of notes. I'm just looking. I'm just being funny today. That's all. Okay, coming down to the point. Okay, so packets. So what do you mean by packets? So packets is how data has been transmitted through internet. So let's say I have to send an image, right? So do you think the whole image goes in 1 second or something? No. When you upload an image on any website altogether, you always see a progress bar like this, right? You see a progress bar, and the progress bar goes something like this. Like it's loading, it's done up till here. I would say it is like pending or something. I don't know. It's like pending, done, 70% or maybe like 30% and stuff like that. So it's loading slowly, and it'll somehow reach up to 100%. Right? That's how you upload a photo altogether. So that's how you upload a photo. So how you think it happens? So basically your photo gets divided into chunks. Okay, so it's been divided into many chunks, and these chunks are then called packets. Many chunks, small chunks, and that chunks are sent through internet to some place where the server is there, and that's how it has been stored. Each packet is not necessary to follow a single route. So what is a route? We already talked about that. We'll talk about it again. So for example, this is my internet. Okay, so let's say this packet goes something like this. This is packet number 1, 2, 3, 4, 5. The packet number 2 goes something like this. Okay, and packet number 3 goes like this. Packet number 5 goes like this. Okay, somehow packet number 4 goes somewhere else, travel weirdly, and then reaches. But so what is the exact thing? How things actually reached? So let's come to that. First packet number 1 got, then packet number 3, 2, 5, and 4. Right. So the packets, these are packet numbers. So how does actually system knows which package has to come first and second? So all packets are having information of indexes. Like this is the packet number 1, packet number 2, packet 3, and 4. But if packet 1 reaches, it will keep the packet 1. Then packet number 3 reaches, it will also keep packet 3, and it will leave the space for packet number 2. As soon as packet number 2 comes, they will fill it. So if you want to imagine it, think like this. You have this thing, okay? So you got packet number 1, you got packet number 3. You don't have 2. 2 comes later on, like, oh, okay, I'm coming, and it comes and it fills. Right? So 2 comes later on, but it gets filled over there. So this is what happens in case of how your data has been sent through it, right? So when these packets are coming, right? So let's talk about here. When the packets are coming to you guys, so these packets already has a port number as well with them. So okay, which port they have to go to? Do they have to go to a web server port? Do they have to go to a streaming server? Do they have to go to a mail server or an SSH? We'll talk about SSH in like 5 minutes. So completely depends on which port the packets are being sent to. I'm gonna go with that till now. So these ports basically define what services we're running and how to actually get to that service. If you see your computer properly, you can also find the ports are kind of like process numbers already running on systems in Windows as well as in Linux and other systems as well. So either you want it or not, your system is currently running multiple ports. Those who have created Counter-Strike game servers, they also have faced problem with ports. You have to set up your ports on which ports you want to run a particular application. Sorry. Port 80 and 443 up till port number 2000, all ports are reserved for particular and specific applications, right? So you have up till 2002, like 2001 up till 9999. These ports are free, and you can use these ports what doubts are being cleared, guys? Okay, I don't know. Someone got someone else. No worries. Okay, going forward now. Okay, so these ports are what do you call it? Responsible for you. What I was talking about? I was talking about ports, right? So these ports are free, right? So 2000 ports are reserved for some specific application, specific stuff. Whereas from 2001 to 999, these ports are absolutely free and can be used in any way you want it to be, right? You don't have to stick to one particular point. Okay, am I good now? Is everyone good with it? Did everyone got what I'm trying to say? Okay, so for example, you create your own application, you want to test that application, you can run that on port number 3000 and it will work. If you want to test another application, you can put it on port number 80 and it will work. But the port 80 is reserved for something, right? For example, let's say like this. Okay. Okay, so let's say something like this. When you open a website, you go to www.google.com. What happens? What have you already know? What happens? It thinks it goes to your IP address, right? Something and something. This is the IP address which it hits to, and then you get a website, right? But it's not a complete thing. It also have your own port with it, which is 80 or 443 by default. This is by default. But some websites don't run a port 80 and 443. These websites are usually on development stage, or maybe one server is running multiple websites. Okay. Give me a moment, Joel. I'm explaining it to you. Just give me a moment. I'm explaining exactly what do I mean by it. So by default, a website goes on with port number 80 or 443. But you can also specify specific ports. For example, there's a website, and you can also specify your own port with it. Let's say port number 3000. And it runs it. So it also happens at one server. Yeah, this one server can run multiple servers on it for different websites. For example, it runs port 80, 3000, 8080, 8000, 8001, or maybe 9000. Right? So all these things are running on it. So when I hit an IP address, so let's call it an IP address, will 3000. That's how you specify it. Dot 3000, like colon 3000. It will go directly to over here, not to port number 80. Get that thing absolutely clear in your mind. When you specify which port I'm going to hit, it will hit to that port instead of coming to this port itself. Am I good with it? So these, when I'm talking about port reserved, I'm talking about, say, that up till 2000 from 0, these ports are default ports for some application or the other. Okay, that does not mean that if I set port number 21 in my system or port number 25 in my system for, let's say, some application, it will won't work, because 25 is for SMTP, right? SMTP is just simple mail transfer protocol. So if 25 is reserved for SMTP and I set 25 for my own application, it won't work. No, that's not true. It will work, but that's not a default standard altogether. Am I good with it? Like, did you got what ports mean? To get into a more extremely weird understanding of ports, let's think something like this. There's a bunch of people. Okay, let me just rub all things together and I will go to the extremely vague explanation of ports. Okay, so let's say there's a building. Okay, a building. Okay, like this. The building have an address. Address is A7215 Punjab. Okay. This is the address of the building. But in the building itself, there are multiple rooms. Okay. Yes, that's right. Okay. By DNS, it has been default set to port number 80. If you want some other port to be used, you have to specify it in your domain name itself. When you talk about Google, you have to say www.google.com and specify port number over here. Let's say 81 or 444, whatever you want to. Okay, you have to specify it if you're talking about DNS. Okay, so this is, let's say, an address. So for example, this house has been given to many small students, many, no, not small, many students altogether, those who are living in it. So for example, let's take names now. Arsh, click over here. So Arsh lives over here. The number of the house is 101, 102, 103, 104, 105, 106, and 107. Okay, so we have 201, 202, and so on, like this. Okay, let's say something like this: 301, 302, 303, 304, 305, 306, and 307, and so on. Okay. Yeah, Ujjwal also living at somewhere here. Okay, let's say Ujjwal. Okay, it's called 203. Let's call it 204, 205, 206, and 207. Okay. Now we have all this house or what, let's call it. Let's have all these rooms inside our house. Now, when someone enters it, right, brings a message, it also should contain where I have to go. Let's say 306, 307, and 305 are reserved or normally being given to owners of the house, right? But let's take another name line now. No, not really. Maybe yes. I will talk about that. Let's take Lakshay now. Lakshay comes in and say, you know what? I have a lot of money. Take my money and give me number 305. It's not about money actually. It's just how it has to be done. Lakshay takes 305. So now it's not reserved anymore. Like, it's obviously reserved, but Lakshay is living over here. But technically, this belongs to who? Let's say it belongs to Jolly. It belongs to Jolly, but now Lakshay is living over there. So when someone comes and courier comes in and say, you know what, this message is for port number 305, it doesn't matter what message is. It will go to port number 305 irrespective of that. The message is for mails or is it for websites or it's for SSH, whatever it is for, it will go to 305 irrespective of anything else. Jolly is not living over there. Lakshay is. Lakshay will get the messages and it will proceed accordingly. Am I good up till now? So port reservation is not really at port reserved for it. This is the usual tendency and this is the usual follow-up things what everyone uses for the port. Are we good now? Did everyone understood what exactly port means and how does port works? Come on guys, I want a yes or no. I think I'm guessing and taking it yes. Okay, good. So now we're good at ports. So now coming back to our thing, right? We got servers. Now we're going back to our cloud. Now let's understand how things are going over here. So you have message, you have servers. This is how people used to manage things previously. They used to have big servers in their offices. 24-hour AC is running through that. Electricity is being consumed. Someone is keeping, like someone has to stay there to actually keep everything is fine on the server and stuff like that. Then came a magic, and someone came with a solution altogether. So what someone came up with? They came up with clouds. Not this cloud. This is different. What they said was, you know what? You don't have to. Let me just rub this thing off. Okay. Okay, so what they said was, you know what? You don't have to worry about all little bit things about managing a server. Let me handle that part. So what they did was, they said, you know what? I will take a big ground, okay, and I will keep multiple machines over there, okay, all the electricity, okay, all the internet, all cooling, everything will be managed by me. Okay, and for that you have to pay me a fee, and you get a machine. Okay, let's say this is a machine, and you take that machine as rent. Okay, for tomorrow example, let's say your business expands and you want to increase number of machines. Just ask me and I will rent you more machines. I'll give you 4 more, 5, 6, 7, 8. I got multiple machines, I got multiple storage. I'll give it to you. And that's how it works on cloud. Okay, so this is what cloud means. Cloud is nothing but a data center, I would say, at a far away place where a lot of things are running together, a lot of data is running together, a lot of things being coming out of it. Like, it is basically a machine. A lot of machines connect together each other to serve a particular purpose, to provide computer to a far away place. That's what cloud means. That's all. Okay, so I will go with it. Like, for example, cloud, AWS is one of the, like Amazon Web Services, Azure, and stuff like that. So these data centers are somewhere far, far in the forest areas altogether. Are we good up till now? So that everyone got what is cloud means. Cloud is nothing basically a computer which is not at your home, it's somewhere else, but you can access it through your internet. And that's all it's all about. Nothing like a big fancy thing. That's all it's about. Okay, so that's how cloud goes. But cloud also helps you, provided you with multiple solutions. Like, for example, you want to convert a video, we have a transporter. You have to set up a mail service, because these things require a lot of efforts from the person who's actually handling all the parts and technicalities of a system. So, for example, you set up credentials, your mail services, your video transmissions, conversions, live videos, and multiple more services are pre-built for you to use directly. To just have to pay a nominal fee for it. So everything you don't have to develop from scratch. Okay. NAS is more of a storage, I would say. It's a different way to store the data altogether. So NAS is part of it. So NAS is completely different from cloud. It's not same as clouds. Okay. Yeah. Okay. So let's see, moving forward now. Let's rub it all together. What have we got? Let's say what's done. So from my side, I would say things blue and red. Cool. Okay, so we're good with servers, done. Ports, done. Cloud, done. Database, let's talk database. Websites is also done approximately, I would say. Yeah, websites is done. You know what websites are. Okay, but we'll talk about website a little bit. We'll see how it goes. Okay. Firewall is one thing, database application penetration testing, and so on. So let's talk about websites. Okay. Websites and apps. And apps. Okay. Okay, guys. So we'll talk about websites and applications together. And let's talk about API as well. We'll talk about this because everything is interlinked and we have to use it. And APIs. Okay, guys. So now come to the bottom point of that's what we're going to hack. This is what we're going to hack. Everything else which I've taught you is basically required for you to actually work on these things. And that's important. So now we'll talk about how you should hack these things and how hacking goes. So websites, applications, and APIs, how these things work. So let's talk about website for now. So websites is what? It's just a website, right? It has many multiple data entries inside it. You read something from it, you upload something into it, and that's how it goes. Like, it's a portal, maybe you have Facebook, Instagram, and many other websites. Now, what happens when you upload something on a website? What happens is it takes the data, give it back to server, and server give it back to you whenever you see it. Now, for example, these websites consist of multiple technologies like CSS, HTML, JavaScript. These are basic technologies these websites are built on. Your browser basically processes this. Now, I'm going to ask you a simple question. For example, we have already talked about how to add data inside an image. Okay, so now if I ask you to add a data, you can add a data inside your image. Am I right? No. So this image. Now, instead of data, how about if you add your code? Now, imagine something like this. You add your code, your JavaScript code inside an image, right? And that image goes to the server and the server responds it back whenever the website opens up. The whole scenario, the whole thing altogether works, right? But when you add the code inside your image, the website will load the JavaScript. For example, it's a JavaScript code. And that code asks the user to actually enter the username and password. And that username and password comes to you. Let's not go too deep right now. So let's say it opens up. Okay, so let's say you have a profile page over here. And this profile, the photo, like this is your page, and you have a photo over here. And whenever someone opens your photo or comes up to this page, this photo has an inbuilt JavaScript written into it, and that JavaScript will be rendered by the browser itself. What happens in that case? The browser will render the JavaScript and it will say XYZ, alert message comes up to you. You have been hacked or something, and it will load that message. So any person who open your profile will get a message, right? That's how you can do something like this. Something else, maybe write a JavaScript code inside this script, okay, and you add your code inside it. So this is where you add your code and add this whole text as a comment anywhere you want to, and whenever someone comes to it, it will see a pop-up or something like that. So this is basically what we call a cross-site scripting, right? You do something on your system, on your profile, anyone comes up to contact with it, gets attached to it. So it's called cross-site scripting. And it can be easily be done on multiple websites and applications, right? All the data which I'm talking about, which has been sent through one way or the other, is sent through APIs. So what is APIs? So let's talk about APIs in a minute, and I will give you a complete brief idea about how to actually hack into systems and do penetration testing and stuff like that. Okay. Something like this. Okay. So what exactly an API is? Whenever we upload a photo or something, or we enter a text to it, it sends the message or whatever you call it to the server, and server responds it back accordingly. And the whole thing which goes through it is done through an API. Okay, it comes and goes, and that's how APIs work. Now, APIs can be considered as a waiter. Okay, so if you want a really vague terminology to it, I would say it's like a waiter. Okay, so for example, you go to a restaurant, you sit over here, your parents are sitting over here, your brother is sitting over here, some waiter comes to you and say, you know what, so this is the menu. You have a menu to you and you. Okay, down out a couple of drinks with it, get some food on the table and stuff like that. So how whole things comes up with you, right? Your drinks, your food, how it comes up. It does not come up like on magically, right? You get some menu, and then you tell the waiter, you know what, I want, let's say this. Your father says this, your brother, your mother says this, and the waiter goes, and this is a kitchen. Okay, it's a big kitchen altogether, and people are working in the kitchen. Okay, so it goes to a kitchen. It goes to the kitchen, gets into the kitchen, and someone is cooking to it, right? So waiter goes and asks for the chef to make the food, right? So the food has been made. You get the food on the table over here, and it gets picked up and comes over here and plays the food right to you. Right? So you are the person, I say, client, who asks for something. The whole system with the chef and everything is what we call server, and the person who's responsible taking the order and getting it done and taking everything all together is called an API. Okay, it is called an API. For the full form of API, just Google it and you'll get to know. That's simple. Like, it's not important. Important part is called an API. So whenever client asks for something, API will get it done, ask the server, and give it back to you. So sometimes happens the food is not good. You say, you know what, the food is not good. Ask the chef to make it again. So what happens? The API will pick up the food, right? Have the food with it, goes to the chef, and you say, make the food again. Now, you being a hacker, you put a couple of chemicals. That's fine. It does. Secure, access, and limited. Now, you being a hacker, what you did was you plant some chemicals inside your food. And when the food reaches the chef and chef try to boil it, it gives a blast and everything goes down. That's one way. Other is you put a microphone inside the food and you say the food is not good, please cook it again. So it goes back to the server, right? And the microphone listens to everything which is being sent around from everyone, right? So that's kind of a malware, right? It's malware maybe. So that's how malware works. It comes to a system, it reads everything, it reads all the data you got and stuff like that, and it gets to you, right? So that's one thing. It's not exactly malware, but that's what you call it, more of basically, let's call it microphone for now. I will tell you about more in deep depth in tomorrow class exactly how it goes. I forgot the name or terminology for it, but it's like let's call it malware for now. Because malware is like a broad spectrum thing. This is specific terminology for it. It just skipped my mind. Okay, so it's a malware. So malware gets everything and give it back to you, and you know what? This is what they're talking about. That's how they're cooking. You have the recipe. Once you have the recipe of McDonald's, yeah, spyware can be said. Yeah, spyware maybe. I guess yeah, spyware is one of the terminology, but there's a very specific event listener. Not really, but let's call it something. But let's call it malware altogether. Don't worry about that. It's fine. It's fine. The point is, now once you have the information, let's say you put the microphone in the McDonald's burger, and now you have the recipe of McDonald's. So you can open your own McDonald's. Let's say, let's pick up a name, Vishal, right? So let's take McVishal restaurant. Great, many entries are there. Everyone is talking about McVishal. Exactly, you replicate everything what they did through your system. Now, don't do it. It's not realizable. Point is, I'm able to make you understand how things goes, right? But some secure, they're smarter people in the world as well, right? So what better do is better take it through some kind of machine where it scans if you have played or tampered with the data. If yes, they will not give it and it will be back, right? So that's one thing. So the point I'm trying to make is there are multiple ways you can hack into a system, but the point is you need to understand is you are the client, data interaction is through APIs, and the server in the back which controls everything. Now you have to figure it out. Maybe you do nothing, you just write a JavaScript code, and whenever someone tries to poke it, it will come up with like a balloon or something, right? So what happens is you take the food and say, you know what, I don't want this food. This is a fresh food. Keep it with yourself. I don't want it. But some other guy comes on some other table, the same food, waiters goes and bring it back to this client, and he looks the food, poke it, and like boom, something comes up. So that's called cross-site scripting, right? Maybe a microphone. Now you're listening to some other client altogether, right? And you're listening to it, and whatever he's saying, and you're getting it. But the point is, it's simple, right? That's how you actually send data and your information through it. Now, let's talk about APIs. So APIs is really a general term, I would say. It's not general. It's that's what happens. Okay. So there are a couple of more things in API altogether. Let's talk about that. So what exactly and how APIs goes and stuff like that. So whenever we use an API, some people what they use is they take a check on the client itself, right? So they check on client and server, right? So whatever you upload a photo, they check on the client and you don't let it hit the API altogether. But now you being a smart guy, but they don't put a check on the server. Server is left alone. So you take the API. So API can be www.something.com/upload. Okay. Now upload has something on it, right? Okay. Now what you do is you /upload. There's already a check on the client on the browser, on the website, but there's no check on the server. So you see what API the client is using. Obviously, it takes time to actually follow it out and think it through, get it done. It's a time-taking job. It's not that simple. You just pick up something and you know what, this is how it's been done. You have to figure it out what API is being used. For example, there is one list of API for the upload is being used over here. You take directly that API and send it to the server. That's one way. And there is no check on server, and server will keep whatever you have given to it, right? So that's definitely one way to get the things done. Okay, so that's how client API and servers hacks and stuff like that goes. Okay, so that's one thing. Okay, I think we're done for what? Penetration testing APIs and websites. Right? So penetration testing is done. Okay, cool. This is an interesting topic. So that's how you penetrate testing and stuff like that. I mean, just think API as your, sure. So API is basically a waiter. Whatever you ask from the waiter, it will take it from some chef or somewhere and give it to you. So API is basically a bridge between client and the server. So whatever things you need is being covered through it. So you can think as Amazon as an API between you and the seller, right? Someone is selling a product, someone is receiving a product, and Amazon acting as a median to actually take something and get it something. Like, it's a part of logistics. Think of API as a courier service. Someone is sending a courier, someone receiving a courier, and the between part is like in API, right? That's how it goes. So when you hit something on API, you get something out of it. That's how APIs work, right? A full form of API. Give me a moment. I just took my mind completely. Application program interface. It's completely useless. I will write it for you guys. Application program interface. I don't know what you will gain through it, but that's what it's called. Application program interface. Go ahead. Okay. Now coming back to our topics now. We'll go with it. Yeah, that's right. I'll just give it to you. Yeah, that's right. Okay, so now we're going ahead now. We're good with it. Malwares. We are somehow done with malwares, but that's not all. So malwares can be downloaded from any website. You get it on your systems, and it will read all your directories, attack on your directories, and stuff like that. We'll talk about malwares in specific malware class. Okay, so we're not going deep into it. So now we'll talk about DDoS attacks today itself. Tomorrow we will see something about database and firewalls. Definitely, I'm going to take it tomorrow. I'll talk about DDoS right now. Let's talk about database and firewall as well. We got time. We got time. We can talk about everything. So let's talk about firewalls first of all. So what exactly firewall is? So whenever something is going out of your system, right? So a hacker puts a malware into your system, right? And the malware reads everything and gives it to the attacker who's there. He's an attacker, right? And this is you running on a simple computer and doing your simple stuff. Yeah, you can say they're similar. Yes, they can. Yeah. Okay, so this is a malware altogether who reads stuff and send it to the attacker. But you have firewall in between, right? This firewall reads whatever is going out and whatever is coming in and decide, and basically it is responsible to allow if data can be sent or not. If it says no, it won't send the data. So that's what firewall means. So firewall is kind of if you have been to mall, when you enter a mall, they check you like this, all literary stuff. When you enter a shop, they check you. When you leave the shop, they check you. If you take something clothing with you, siren goes off, right? Oh, this someone is trying to steal your data. That's what firewall is like, right? It checks whatever data is going out of the systems if it's right. So firewall is basically used in case of your big offices, right? So they have multiple people connecting to it and everything. They are running their own systems and they have a firewall. So that firewall decides what all data can come in and goes out. So stop everything from going, like, basically stop like important stuff to go out of the organization without them knowing that. Yeah. Okay, guys. Yeah. Now we'll talk about DDoS attack. Okay, so I think this is good enough for you. Three-way handshake is not required for you right now. Definitely I could, but that would actually take a lot of time for everyone. Okay, now talk about databases, guys. So databases, I would say, we'll go with DDoS and everything. Let's talk about database and wrap it together. Okay, sure. Your three-way handshake is, it's basically we're going. Okay, let's see if you got time in the end. I will talk about three-way handshake as well. It was basically TCP handshake and stuff like that. We'll talk about it. Okay. It's a filters data. It even stops the data being going out from. It will stop the request altogether. Not even filters, but yeah, you can say filters as well. Definitely, that's one introspection through it. Definitely. Okay, database. So what exactly do we mean database? Database basically means it's kind of a container which has entries into it. It's called a database. Right, so it can be let's say there's a table, right? It contains your name, roll number, and stuff like that. Okay, so there's an entry through it. All the data has been put to it, so there are multiple entries inside it. You read the entries, you serve the entries, and do stuff like that, right? But all the data is stored is called a database. That's how things goes in the database. Now the interesting point of database. So in any application, you will see a really smart application. I would say, not the dumb applications. The smart applications, the good applications, not the websites, I would say, not the website which you guys sometimes make on simple HTML, and you know what you call it, like, you know what, I need a website, not about that websites. So what happens is, what all things are there is a front end. Okay, there's a front end to it. That's the one thing. After the front end part, your comes APIs. That's one thing. Your comes your server, or I would call, yeah, let's call it server. The server again interacts with something called as database, right? It reads through database, write to database, and serve whatever is being required to you. Okay, that's how normal these systems work. The whole part from server and database go and call as backend. Right, the whole part is called backend. Database have multiple entries inside it. These entries have been read through servers and then it's been served to the client. That's how things goes. The database can be of multiple ways. It can be a let's say the database can be an SQL database. It can be your Mongo or like NoSQL database. Let's call it NoSQL, and so on. So SQL, NoSQL is completely different. We're not going to talk about that. So your Postgres database, NoSQL, MySQL, and like MongoDB. There's a little wide list of databases. I'm not going into depth of exactly what all databases are there. Yes, they do. So database also has its own server. It's called a database server, and it resides on a port. That's how you get to it. Definitely it does reside on a port. It's not an open-ended way. It does reside on a port. You have to specify which port database is running on, and you have to hit on that port to get the data. Right? Everything goes through a port. The port is the game, guys. You need to understand ports. Port is the game. Definitely, yes. Okay, so we will learn SQL also. Not really. We'll learn SQL. Maybe I'll give some tips and tricks about it, so you can move forward with SQL injection. How does that work? We'll talk about SQL injection definitely. So for that, you need to know SQL. So that's what I'm telling you how databases go. Okay. So what is SQL injection? How to hack into that? I will just give you a brief idea about it. So for example, you put an entry to it. Okay. Now the SQL databases always have a query. Like for example, select star from student. So this is a query, right? So what does this query means? It means to select all the columns. Star means all the columns, like phone number, name, blah 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 blah, email address, parents name, your scores, your grades, and everything from students. If I write this thing in the front end, the API will take it forward, server will take it, and if server is trying to go things directly into it, It will run the query on the database, give you the result, and this is wrong way to do it, right? Because you should not get the data for all the students. That's hacking, and that's how Sql injection works, right? So you go to one part, you hit to it, you get it, right? So to do that, you basically try to hack into API and basically select that. So I'm not going to that part. That's not what I mean to do. Now, let's quickly tell you about DDoS. What is DDoS and stuff like that. Okay. Cool. So what happened in DDoS attacks? Something like this. Let's lay it out with this. For example, this is my server, right? Server serves multiple requests to the front end, right? So for example, someone is using like this, and many other, right? So many people are using it, many browsers are open all together, and this is a server, right? This is a server which is giving you websites to work on. Okay. Yeah, that's what I'm trying to do. That's what I'm trying to do. What happens? Wait. So what happens in that case is when many people, okay, so many people all together when hit on a website, right? What do you mean hit on a website? When they call for it, you know what? Open the website for me, right? So when many people all together ask the website to open, server get multiple requests, right? So gets the request, gives it back, gets a request, gives it back. But when it has many requests all together, a queue gets formed on. Man, like for example, let's say like 5 students are asking me questions. I can answer all of them. Now imagine when 5,000 students are asking questions to me. What happens in that case? I'm not able to answer all the questions. I will start from 1, 2, 3, 4. After 10, I get all fed up and I just stop answering them all together. That is what we call denial of service. That server gets so much data on it, so much asking from it. You know what? Answer me, give me website, give me website, and everyone's talking about website. Server gets so much overloaded, it just denies the service altogether. It's, you know what? I'm not giving you anything you want, and that's how you do it. So when some websites, smaller startups are going to their website, they have a small service. When you attack with multiple like for example, a whole class, let's say whole school, let's say whole daily plan to make a website down, they all will do what? They will all open a single website together. The website gets so much traffic is multiple people are looking through it. The servers go overshoot and they shut down, which is called denial of service. What happened in case of DDoS? When many small computers all together are running all together, but some attacker, so some big attacker, put small malwares in your systems, and these are dead malwares. They are not working right now. They are absolutely like dead. They're not working anymore. But as soon as the attacker sends them a signal, let's call them like a sleeper cell. You know what sleeper cell is? No worries. But let's call them sleeper cell or something like that. So everything is sleeping and everything is like going off. They're just relaxing. As soon as someone triggered them, you know what? Active. They all will hit one website together and they bring the server down. That's how it goes. For example, on my system, there is a there's a malware which is resting on it. It's not harming my computer in any way, but when they get a signal, you know what, I want to break this website down, it will just hit to the website through my system. Even I won't know that my website is asking for that request, and it will bring it down. Right? That's how DDoS work. Now it's really difficult to make a DDoS attack depending upon multiple systems you need. Servers are much stronger. You have clouds and everything, so it becomes extremely difficult to do a DDoS attack, but it still can be done. It's not an impossible thing. Many websites, have you ever heard like Amazon got down through sale? Sale start hui, Amazon down ho gaya. Reason was denial of service. Many people started a request on it कि मुझे भी चाहिए. When you get a lightning sale of phones or something, website down हो जाती है, दिक्कत करती है. So that's basically how DOS, denial of services, works. So DDoS is basically sending the same request through multiple channels and multiple areas. Because अगर आपको मैं वेबसाइट में एक जगह से अटैक कर रहा हूँ तो आप इसको ब्लॉक कर दोगे, मुझे यहाँ पे देना ही नहीं, मैं बाकी जगह दूंगा बट इसको नहीं दूंगा, राइट? उस केस में डिनाइल ऑफ सर्विस, हम डायनामिक डिनाइल ऑफ सर्विस करते हैं, राइट? डीडॉस मींस डायनामिक डिनाइल ऑफ सर्विस. यहां से रिक्वेस्ट दी, आपने इसको ब्लॉक करा, मैंने यहां से दे दी, आपने इसको ब्लॉक करा, मैंने यहां से दे दी, फिर यहां से दे दी, फिर यहां से. आप सबको तो ब्लॉक नहीं कर सकते. दैट्स हाउ इट वर्क्स. Okay, guys. So I think that's all for today. Okay, so it's being a good lecture, I would say. Everything is covered. Tomorrow we're going to talk about something really interesting. Not talk about. Tomorrow we're going to do something really interesting. We'll try to hack into something, and we'll see how it goes. It goes good or bad, we'll see. Okay, guys. Thank you for saying OP lecture. Thank you so much. Yeah, so guys, don't forget to like, subscribe, and share. You're not sharing with your friends. I'm not sure if you are, if you're not. Just let everyone know. Maybe your teachers know that someone is teaching good, and let them know, and let them also benefit from it. That's all for it today, guys. Thank you very much for watching. Bye bye, Tata, see ya. You can call me on Discord. You can connect me on Discord. I will reply to everyone you want to. You can also comment, like, talk to me on Telegram and stuff like that. So that would be cool. It's a surprise we'll get to in the morning itself. Yeah, sure. I will come to Discord after 11 o'clock today itself. So after 11 to 12, I'm available on Discord. You can message me at that time. No worries. Thank you so much for being an OP. OP Nalin, OP, yo. Well, guys, bye-bye, tata, see ya. Sayonara. Bye. Yeah, I will come on Discord at 11 o'clock. That's what I said. 11 o'clock, I will be available on Discord. Yeah, bye.